Hello everyone, my name is Nossayba Darraz from University Sidi Mohammed bin Abdullah from Fez, Morocco. Thank you for having me at the International Conference on Intelligent System and Computer Vision. Today we share with you our insights into the exciting world of improving hybrid recommendation with VADER-Powered sentiment analysis. Now, let's dive deep into the core of our study. In the content of our presentation, we'll start by introduction and the literature reviews to exploring the existing body of knowledge, diving into relevant studies that guide our research. After that, I'm going to talk about the methodology and we'll see the experimental results. Finally, we will conclude our main topic. First of all, we start to talk about recommendation system and the challenges they face. Let's start with the definition. So, recommendation systems are intelligent algorithms that provide personalized suggestions to users. So, it's like your personal shopping assistant using smart algorithms to suggest products or content specifically chosen for you. Now, one of the significant challenges that recommendation system encounter is the issue of cold start users. Imagine you've just joined a new streaming service and it doesn't know what you like it. That's what we call a cold start user. It's tough for recommendation system to give accurate suggestions until they learn more about you. Another challenge we face is data sparsity, which refers to limited information on users' preferences and item characteristics. There's a valuable solution to this problem. User-generated text such as comments, reviews, and feedback. This text provides us with valuable insight into user preferences and opinions. This is where sentiment analysis comes into play. So it's like having a superpower to read between the lines of those user comments. We can extract emotions and opinion from them. Understanding sentiment is key. It's not just about what you buy, it's about how you feel about it. Positive reviews may mean you love a product, while negative ones may steer you away. These insights help us make recommendations that match your preferences. In addition, sentiment analysis isn't just for improving recommendation, it also gives us a pulse on what's popular and accepted by users. It's like having a direct understanding of the market's trend and preferences. So we discussed three interesting approaches that leverage sentiment analysis to enhance recommendation system. In the first work, it's look at user reviews and use sentiment analysis by checking out how people feel in these reviews. The system gets a good idea about what users like, not just based on numbers. That's why it does better than basic method on Amazon data, giving suggestions that are more accurate and just for you. And what makes it even cooler is how it mixes sentiment analysis with collaborative filtering. Next step is how sentiment analysis is mixed into the KNN algorithm instead of just looking at numbers. This way, use sentiment score from 31 net plus it brings in method called ARP, which check out how much people like stuff. By adding sentiment analysis and ARP, it does better than usual on the dataset like Yelp restaurant reviews and Data Affinity hotel reviews. It's a big improvement of the for the KNN algorithm. Lastly, we have the work use hybrid movie recommendation system. This work combines collaborative filtering, content-based filtering, and sentiment analysis of tweets for personalized movie suggestions. By leveraging the movie tweeting database and VADER sentiment analysis tool, it aims for more accurate recommendation tailored to individual preferences. In this step, we will explain the workflow of the methodology that we are going to propose. So we talk about the methodology behind our innovative hybrid recommendation system. Our main aim was to make user recommendation more accurate and reliable. To achieve this, we added sentiment analysis of user reviews or comment to our traditional recommendation technique. To achieve this, we combine three powerful approach: collaborative filtering using SVD with parameter, content-based filtering using lasso regression with TF-IDF, and sentiment analysis using VAD. By using collaborative filtering with SVD and parameter, we tapped into user data to understand their preferences and item characteristics. Through content-based filtering with lasso regression and TF-IDF, we leveraged business data to enhance our recommendation. Furthermore, sentiment analysis using VADER helped us extract sentiment information from user reviews or comments by considering the positive or negative sentiments associated with specific item. By using all this method together, our hybrid recommendation system gave better and personalized suggestions. It looked at how users act, what products are like, and what people say about them. In this slide, we highlight the significance of the Yelp dataset, which was published in 2017 for our research on restaurant recommendation and sentiment analysis. It provides detailed information about businesses, user reviews, and reviewer attributes, allowing us to develop accurate recommendation model tailored to individual preferences. This dataset serves as a foundation for our study, enabling us to enhance the user experience and improve the accuracy of our recommendation. The slide outlines the methodology employed in our study to evaluate the performance of our recommendation model. It highlights the use of the cross-validation, specifically 8-fold cross-validation with the cross-validate function, and underscores the evaluation metric used, which is root mean square error. The figure presents a bar plot that compares the RMSE evaluation for different similarity measures used in collaborative field study. The methods being compared are cosine user-to-user, SVD, SVD tuning, SVD++, and SVD++ tuning. The plot includes two sets of bars, sentiment writing in blue and original writing in orange. Interestingly, SVD tuning demonstrates the lowest LMSE of 0.9216 for sentiment writing, indicating its efficacy in capturing user preferences. The table provides a concise evaluation of content-based filtering model using different similarity measures combined with regression algorithm. The method employed include TF-IDF with linear regression, k-neighbors regression, lasso regression, and ridge regression. The table presents the corresponding LMSE score for sentiment and original writing. Remarkably, the TF-IDF with lasso combination exhibit the most favorable performance in predicting sentiment writing, achieving a lower MSE of 0.9217. This figure compares different recommendation models based on their evaluation metric score. The collaborative filtering model achieved an LMS score of 1.1976, while the collaborative filtering with sentiment writing model significantly improved performance with an LMS score of 0.9216. Similarly, the content-based model obtained an LMSE score of 1.21, while the content-based with sentiment writing model showed notable enhancements with an LMSE score of 0.9217. However, the standout performer in this comparison in our proposed approach, the NMF and decision tree regression-based hybrid recommendation system, outperformed on other models with an impressively low LMSE score of 0.092. To conclude, our paper brings significant advancements to hybrid recommendation by incorporating sentiment analysis. We leverage SVT for collaborative filtering, TF-IDF with lasso for content-based filtering, and VADER for sentiment analysis as key component. The integration of sentiment writing from user reviews enhanced recommendation accuracy and personalized. Notably, our NMF and decision tree regressor-based hybrid recommendation system outperforms on other models with an impressive LMSE score 0.092. This demonstrates the effectiveness and strength of our approach in delivering highly accurate recommendations. So, these references relate to previous work and the data utilized in our research. Thank you very much for listening and your attention.